All right, so this is where the last video left off. I didn't want to do it all in one video in case you needed to take a break. Plus, I had to stop and start recording again, so it was easier for me to upload them as two separate videos. So anyway, this is where we left off. We'd graphed the absolute value function. We talked about the absolute value being the distance a number is from 0. Okay, and on your Desmos, if you should put your parent function, y equals the absolute value of x. Looks like this, what we just drew. If you're looking for the absolute value bars on Desmos, they're right here, right above the ABC. Okay, it's got the bars on the outside of the little letter A, and that'll give you the absolute value bars. Just remember, when you're typing, you need to hit the bar first, type what's inside, and then hit the bar to close it. It works just kind of like parentheses do. All right, so what we want to do is we want to now take this function and we want to do some manipulating of it because we want to work with the function y minus k equals a times the absolute value of x minus h. We want to be able to put numbers in these places of h, k, and a and figure out how that changes what the graph looks like. All right, so let's move on to this page here. You'll see that's that same equation. And what we're doing with these four functions is we're going to go ahead and put them in Desmos, and you can see that our original function has x minus, so what we're doing here is we're making h equal positive 3. What we're doing with this one is we're making h equal positive 1. The only way we could get a plus sign here, if the original equation was a minus sign, is if this was y equals the absolute value of x minus a negative 4. Okay, so that just got simplified to plus. So here h is going to equal a negative 4, and here h will equal a negative 2 for that same reason that it was a minus a negative. So go ahead and graph those four, pause the video, and then come back, and hopefully you'll get the same result on what adding that number in there does. Okay, so when I take these four and I put them into Desmos, what I end up getting, my x minus 3, you can see my original graph's still on there. If I put on x minus 3, you can see what happens is, because my h value was a positive 3, it went 3 spaces to the right. When x was a positive 1, I had x minus 1, so h is a positive 1, it moved 1 space to the right. When h was a negative 4, h was a negative 4, it moved it 4 spaces to the left. And when h was a negative 2, because it says plus 2, it moved 2 spaces to the left. So you can see that by changing the h value, what we're actually doing is sliding the graph left and right. And I could actually add a graph in here to where I say y equals the absolute value of x minus, and I'm going to use the letter h, and it's going to say, do you want to add a slider? I'm going to say yes. Okay, and I'm going to turn the other graphs off, but leave on the original function. So you can see any number that I put in, I'm not sure why that one's still showing up there. Oh, because it's this one here. Any number that I put in for my h is going to slide my graph, if it's a negative number, to the left, and it's going to slide my graph to the right if it's a positive number. So I think sometimes the slider actually helps make it a little bit easier to see what that value is. Okay? All right, so what we can now do is we can now say that h moves the graph, translates the graph horizontally. So the other thing we can say, that's number one, the other thing we're actually going to be able to say as well is that h is the x coordinate of the vertex, or that minimum or maximum point basically. Now, if you're filling in the section that says what's the effect, well, if h is positive, the graph translates right. And if h is negative, the graph translates left. All right, so we're going to go ahead and do that. That was just h, but now we're going to go ahead and change the k value. So we're going to go to the next box and actually change just the k value so we can see how that will affect our graph. Okay, so here are the 4 that I want you to graph on Desmos. So in this case, same issue. We already had a minus sign, so that means in this case k is positive 2. In this case, k is positive 5. This one, k would be negative 3, because in order to get that, we need y minus a negative 3, right? And this one, k would be negative 3. So go ahead and put those 4 on your Desmos graph and see if you can figure out what happens to the graph when we change the k value. All right, so I have these 4 on my graph. Pull that up here. And this is the one where k was equal to a positive 2. And check out what happens to my graph. It slides up 2 spaces. When k was a positive 5, the graph slid up or translated up 5 spaces. When k was negative 3, the graph slid down, translated down. And when k was a negative 5, it translated down those 5 units. And again, I can go in and I can put an equation that has that in as a k value. So when y minus k equals the absolute value of, did I forget I need to add the slider, equals the absolute value of x. And if we change that k value, we can see when k is positive, it slides the graph up however many units, and when k is negative, it slides the graph down. All right, so when we go back and look at this, we can say then that the k value translates the graph up and down, which is vertically. So if k is positive, this time we'll do a plus sign, the graph translates up, and if k is negative, the graph translates down. All right, so we're, again, this is kind of like a science experiment. We're keeping everything else constant and just changing that k value to see how the k value affects the equation. When we get all done, we're actually going to change all 3, the h, the k, and the a, and see how everything ends up that way. So the next one we're going to go on to is changing the a value. So we've changed the h. We've decided that that's the x coordinate of the vertex. And now we've changed the k, and the k is the y coordinate of the vertex. It's nice to know those two, the x coordinate and the y coordinate, because then you can just place that point there. Okay. And then now we're going to change the a value. So this one is going to be changing that a value. You can see I changed it to a positive 2. So here a equals 2. Here a equals 1/2. In this third one, a equals negative 2. Okay, so we're going to be able to see what a positive and negative do here. And here a equals negative 1/2. So go ahead and graph those 4 on your Desmos, pause the video, and come back when you think you know what a changes. All right, so now I'm going to take these onto Desmos. I'm going to see what happens. So I'm going to turn on the graph that's y equals 2 times the absolute value of x. and the graph got skinnier. Basically what's happening is the original graph had a slope of 1 and -1, and this new graph has a slope of 2 and -2. Okay, so it made it skinny. What happens when I turn on 1/2? It made it fat. So the original graph had a slope of 1 and -1. This slope is now 1/2, rise 1, run 2, and -1/2, okay, or the opposite of 1/2. But what happens when we put negative signs in front of those values? Well, when I do the -2, it's skinny again, but this time it opens down. So it changes those slopes again to 2, basically. We're having a slope of 2, one being a -2, one being +2, but it reflects it over the x-axis. And same with that -1/2. It still keeps it fat like we were expecting because it's growing slower, but now it's in the bottom two quadrants, quadrants 3 and 4. Because of that negative sign, it reflected it over the x-axis. Okay, so we can see here that if we just turn on this with the A slider, whenever my A is positive, the larger and larger my A gets, the skinnier my graph gets. The smaller and smaller A gets, the fatter my graph gets because it's growing slower. Then as soon as I flip to the negative numbers, then it reflects over the x-axis. And again, the further away from 0 I get, the skinnier the graph gets. All right, so we're going to try and describe all of that on here. So A changes the slope of the lines. All right, so what we said is if A is positive, and it could have two things, large, so like a +2, okay, we ended up with a skinny graph, right? And if it was positive but small, like the 1/2, we ended up with a fat graph. But then if A is negative and large, like -2, we had skinny, and this time it opened down, where this one opened up. And when it was negative and small, like -1/2, it was fat and opened down, where this one opened up. Okay, so we're going to put all of those pieces together, and I'm going to show you the graph with all of the sliders and how the entire graph can change based off of the A value, the H, and the K. So let me go back to Desmos real quick. If you're not done writing it down, just go ahead and pause. All right, so let me turn this one off. And I actually want to turn on this graph. You can see I have all the pieces in this equation right now, and I still have my original parent function up there. When I have that there, I can change the H. Let's say it's 0. Let's take the K back to 0. Let's get everything starting at 0 for us here, okay? All right, and let's take the A to a +1, because that's what we're used to it being, to a +1. That's the original parent function, okay? Let's say I changed my H value to +5. You can see I moved the graph over to the right 5 spaces. Let's change the K value to -5. And then let's make the A value a +3. So we had 3 things affect this graph. We translated it in the horizontal direction, 5. We translated it in the vertical direction, -5. And then we also changed the growth rate, or the slope, to a 3, a +3 and a -3. Okay, so just by looking at those 3 numbers in our equation, we can make a prediction as to what the graph's going to be. And that's what we're going to do next. All right, so looking back here, we want to go ahead and make a summary of all this stuff. So H shifts the graph horizontally. K shifted the graph vertically, and it caused our vertex to move from 0, 0 to whatever h was and whatever k was. When a was a positive number, the graph opened up. When a was a negative number, the graph opened down because it reflected it over the x-axis. All right, so let's see if we can apply all these things to some equations. So what's going to happen? Real quick, I want to go ahead and label these things. I want to know what h is, I want to know what k is, and I want to know what a is. All right? So h, I look right here, and this says plus 1, so that means it was actually minus a negative 1. So h is negative 1. The k value, it says minus 3, so we just look at the 3, so k is 3. And for a, I look in front of the absolute value bars, and there's no number written there. When there's no number, we know it's a 1. So we know the slope of our lines are going to be 1, but we know the vertex is going to be at negative 1, positive 3. Our a value is positive 1, so our graph is going to go up 1 block and over 1 block. And then we do the mirror image of that to do the other side. So now we can answer all of our characteristics based off of this. So go ahead and pause, and you try and answer them. Start it back up and see if you get it right. So the domain of this function is x equals all real numbers. The range is that y is greater than or equal to positive 3. The minimum of the graph is the vertex, negative 1, 3. There is no maximum. It's increasing or going uphill when x is greater than negative 1. It's decreasing or going downhill when x is less than negative 1. The end behavior, remember, is just that fill in the blank. So as x approaches infinity, y approaches. Well, so as x gets bigger and bigger, y is going to get larger and larger. So it's going to positive infinity. As x approaches negative infinity, so as x gets smaller and smaller, my y is getting larger and larger again. So y is approaching positive infinity. This graph is neither even or odd because it never goes through 0, 0. It had the chance of being even because it was a reflection, but it didn't go through 0, 0. And I believe you have one more question, which is the axis of symmetry. So if it's not at 0, 0, if it was, the axis of symmetry would be the y-axis. But because it's not, the axis of symmetry is going to be the line that cuts it in half vertically. And that's that line right there. And that line is where x equals negative 1. That's your axis of symmetry. Again, if you need to, pause it so you can write it all down. The next graph, we have 3 different things going on here. Let's get a darker color for this so I can see what I'm doing here. So I'm going to read my h value. H equals 1. Read my k value. K equals negative 4. All right, and my a value is 2/3. So I already know that there's a translation vertically, horizontally, and that my slope is actually going to make my graph fatter than normal because it's smaller than 1. All right, so my vertex is now at positive 1, negative 4. And from there, I'm going to go up 2 and over 3. Up 2 and over 3. And I do the reflection of that to get the other half of the graph. And there is my absolute value graph. Okay. It does have a minimum. It's going to be at the vertex, which was 1, negative 4. The domain is x equals all real numbers. The range is y is greater than or equal to negative 4. It's increasing after the axis of symmetry. The axis of symmetry is at x equals 1. You have that. That's x equals 1. And it's increasing after that, so when x is greater than 1, it's decreasing before that. So when x is less than 1, the end behavior, so it all fits, as x approaches infinity, y approaches, as we're going this way, y is increasing, so infinity. As x approaches negative infinity, y approaches. So as we go this way, y is getting larger, so we have infinity. Is it even or odd? Again, the first check I do is, does it go through the point 0, 0? And it doesn't. So my answer is neither. Okay. All right, I'm going to the next graph here. And take a second and try and do it yourself. Pause the video. See if you can get the H, the K, and the A and answer any of the questions. Maybe put the graph on. But I will warn you right away, this 4 is on the wrong side of the equation, isn't it? Let's subtract 4 from both sides so we can get it on the correct side. So our equation is actually y minus 4 equals negative 3 times the absolute value of x plus 3. Okay, so pause here, try it yourself, come back and check. H equals negative 3, K equals positive 4, and A equals negative 3. Oh, negative 3? That means it's going to open down and be skinny. Okay, so we've got to be prepared for that. So H is negative 3, and K is positive 4. And I know it's going to open down, so I'm going to go down 3 and over 1. Down 1, 2, 3, and over 1. 3 and over 1. And then I do the reflection of those points, basically. And I have a skinny graph that opens down with a vertex of negative 3, 4. So my vertex is negative 3, 4, but this time, because it opens down, it is a maximum. The domain is still x equals all real numbers. The range this time is y is less than or equal to positive 4, because it opens down. And this time it's increasing where x is less than negative 3, because it's going uphill before it hits the vertex. And it's decreasing where x is greater than negative 3, because it's going downhill after the vertex. Okay, let's try another graph. Pause, you try it, and then come back. So H equals 4, K equals 2, A equals 1/2. That's a positive number, so it'll open up, but it's smaller than 1, so it's going to open up fat. Okay, so H is going to be at 4, K is going to be at 2, and my slope is 1/2, 1 over 2, 1 over 2, 1 over 2, over 2. All right, so there is my graph of my absolute value. Okay, and I do have a minimum this time, which is 4, 2. The domain is x equals all real numbers. The range is y is greater than or equal to 2. It's increasing where x is greater than 4. It's decreasing where x is less than 4. The end behavior, as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches positive infinity. And it is neither odd or even. All right. So there's some more. I'm not going to do these with you. They're great practice for when you're studying for the test, which is supposed to be next week. It probably will get pushed back. Okay? These are great because they want you to try and do it without graphing it. Just picture the graph after doing them so many where you're graphing them. Now just picture the graph. So what is the vertex of this graph? Well, my H is negative 5 and my K is negative 3. I should be able to pull the vertex directly out of the equation. Oops, I kind of wrote that in the wrong place. Let me write that in the right place. So -5, -3 is that first one. Okay, if I slide down, okay, well, I need to get the 6 to the other side. So this would become y plus 6 equals the absolute value of x minus 5. So, absolute value. So that would put my vertex at 5, -6. Okay, so those are some great ones to try, to test and see if you can still pull out those pieces. All right, so this is the closure for today's class. If you can do this, then you've learned the pieces that we were looking for. All right, your homework assignment is a handout that the substitute will give you. And it looks, let me pull up the document here. It looks like this, okay? And you can see it's just like what we've done in class. There's absolute value equations. You graph them, and then you fill in the characteristics. There's 5 of them. And I will see you tomorrow. I'll see you on Friday.